Hey guys, welcome to SkillLink. Assume that you have a rubber band in your hand. When you stretch it, the band expands and its length changes, right? Meanwhile, it returns to its original state as soon as you leave stretching. The change in the length of the material during applied stress is known as deformation, and the ability of the material to regain its original shape is known as elasticity. But elasticity isn't always permanent. When the stretching force exceeds a certain limit, the deformation stays and the material remains deformed even after the removal of force. This condition is known as plastic deformation. In this video, we are going to discuss the mechanisms of plastic deformations, especially in crystals. So let's get started. Almost all materials are subjected to certain types of loads when they are in service. The force may be tensile, compressive, or shear in nature. All these forces, when applied, create a deformation. The deformation might be a change in the shape or size of the material. Deformation can be either temporary, known as elastic deformation, or permanent, known as plastic deformation. Almost every material exhibits elastic deformation up to a certain limit. This limit is called the elastic limit. The stress applied and the strain developed in the material will be proportional within this particular limit. When this limit is exceeded, the deformation becomes irreversible, known as plastic deformation. Plastic deformation may also lead to fracture. In order to avoid problems due to failure, it is necessary to study about deformations. As we know, deformation is the change in the shape or size of the material. But do you think there is any change in the crystal structure of the solids due to deformation? Well, there are three possibilities for a crystal to deform. The crystal structure may either change, remains the same, or it may get distorted to become amorphous. The X-ray diffraction experiment of crystals shows that the crystal structure remains the same after deformation as well. So what exactly happens inside the crystal? Plastic deformation can occur in two ways. One is through slip mechanism and the other is through a twinning mechanism. Slip is a prominent plastic deformation mechanism in which parts of the crystal glide over one another. The slip phenomenon looks more or less like slided cards in a deck. The crystal defect that arises due to the misalignment of atoms is known as dislocation. The dislocated atoms generally move over the crystal during slip. If the dislocation arises due to the distortion existing along the extra half of atoms, then it is said to be edge dislocation. On the other hand, if the line of distortion due to applied force passes through the center of the atomic plane, then it is said to be screw dislocation. A plastic deformation may arise due to either edge dislocation, screw dislocation, or the combination of both. The mechanism of slip deformation looks similar to the caterpillar motion, where a hump moves over the body of the caterpillar. In slip, the distances moved by the atoms during deformation will be the same throughout. The direction in which the slip moves is known as slip direction, and the plane in which the slip occurs is known as slip plane. The combination of the slip plane and the slip direction is known as the slip system. For a particular crystal, the plane that has more number of atoms will act as the slip plane, and in that plane, the direction which has more atomic density acts as the slip direction. The marked plane in the face-centered cube has more atoms than any other planes, and so it acts as the slip plane. The slip mechanism is continuous and throughout the structure in case of a single crystal. But when it comes to polycrystals, the grain boundaries in them affect the slip, which in turn makes the slip orient in different directions in different grain boundaries. Now, let us see what twinning is. When the shear force applied produces atomic displacement that makes one side of the crystal look like the mirror image of the other, then the deformation mechanism is said to be a twinning mechanism. The plane at which the twin occurs is known as twin plane, and there may be two or more planes present during the twinning mechanism. The shear force required to cause twinning deformation will be more than that required to cause slip deformation. So that's it for this video, guys. I hope you all understood about the plastic deformations in crystals. We'll meet up again in the next one. Until then, bye.